Well, everybody, here's a quick intro to this video. What you're about to see is someone tear into his Vevor MX400, WM210, MX600, 700, 800, whatever the model is. But this particular style, typically a lot of them are WM210s. This particular style headstock, I'm tearing into this video. I discovered that my bearings, there was some grease leaking out of it, so I thought that it had sealed bearings. I thought those were shot. So I decided I'm going to investigate this and find out what's going on. Never dealt with bearings. I'm a hobby machinist, not a mechanic. So all of this is brand new to me. So you're going to watch me learn, go through the experience, and hopefully capture some visuals that might help you if you need to tear into your headstock spindle and investigate any problems. So you can see what you're in for before you actually start it yourself. So I hope you enjoy this video. Thanks for watching, and let's get started with it. Well, everybody, it's a sad day for Dee's workshop. I fear that we have got a long time coming problem that I now have to address with this lathe. A while ago, I thought the headstock bearings were going out. Turns out it was the tensioner pulley, and that was causing the issues. This thing's been running a lot better. Still dealing with some of that stuff. But I noticed after, in a previous messing in the shop video, I mentioned it, I noticed a streak of oil or grease coming down behind where the seal is, behind the chuck. And I smelled it, and it smelled like grease, not oil. And I was like, that's not good. Now, I had worked with something very rusty and spraying a lot of oil, and I thought, well, maybe oil and rust got back in there, and that's just residual mess and just kind of dripping down. So I cleaned it up. I've been paying attention to things, but it's not going to stop me from using the thing. And today I'm working on my larger screw clamps, but I worked on the screws for those. And this morning I noticed there were some more streaks of oil coming down that was dark in color, resembles grease. So I cleaned it all up, and I said, I'm going to do this project today, and then I'll come back and review it and clean it. So I finished that project, and then I sprayed some WD-40 while this thing was running back here, and a lot of dark oil or grease was coming down. I fear that the seal is bad on this, at least this front bearing, and I'm going to have to address it one way or another. There's many options. Get a new lathe, try to fix this lathe. I don't know. This is going to be how I start the new year, 2025. Not really what I wanted to do, but it's part of it, and I'm stuck with the hobby now. I love it. So one way or another, I'm gonna have a lathe running, and we'll see what happens with this year. But this needs to be addressed. I can use it, but once it seizes up, it's not going to be good. Plus, it's going to affect accuracy. And as I continue with this hobby, I'm working on trying to be more precise and hitting all of my marks instead of just, roundabout rough measurements. So I'm not going to be able to do that if the bearings are shot and this thing moves 2, 3, 4, 5, 10 thou, whatever it ends up being. So I'm going to get you down here. This is going to be I don't know how long this video is going to take for me to create. It's almost Christmas right now. So this won't come out until next year sometime because I got to address this thing. I got to figure out how to do it. I don't think I have the right equipment to do all that. I just got to figure it out. So we're going to do that together. I'm going to share that experience because that's how this channel started. Working with this Vevor mini lathe, showing you all the problems that come with it. And lo and behold, we got another problem with this thing. So it's going to be wrapped up in the year 3 review, which will come out in July. But we got to see what we can even do with this thing. Can we salvage it, or is it done? We will find out together. Now, I'm going to bring you down here. I'll show you exactly what I'm talking about, give you a little bit closer visual, and then we'll see where this video takes us. I don't think that's good. What I did was I turned it on, spun the chuck, and sprayed some WD-40 back here, and it's bringing out some junk. At first, I thought maybe that was just rust from that machine, that thing that I was working with, but I'm not so sure. I'm worried that these bearings are leaking. I got some things to think about, I guess, huh? Kind of hard to see in there, but yeah, not so good. I really do not want to tear into that headstock. Maybe it's an impossible task, but before I throw this thing away, I would at least attempt it. You can see, well, I cleaned it up a little bit, but you can see there's some dark oil. I've been squirting some oil back in here behind it. But what we're going to do is I'm going to turn this thing on, and I'm going to spray some WD-40. You can't really see it, but there's a seal back there. I'll show you in a second. Actually, I'll show you now. But this is what I'm talking about. The seal back here. I'm going to spray some WD-40 as it's running, and we'll watch and see what I'm talking about. Let me bring you up a little bit so maybe you can actually see all of that. All right. Let me show you what we're dealing with here. I'm going to turn this on. I'm going to squirt some WD-40. And you kind of see just how dark it is. I think that's what that's doing. I think there is, it still could be dirt and debris. Like, this thing's spinning fine. What I think I'll do after this clip is take the side off, and we'll take all the gearing, the banjo off, and then we'll just see if we can hear any noises. But for now, you can see it's cleaning out. It was a whole lot dirtier earlier. Let me turn this off. It was a whole lot dirtier earlier. You can see this rag. But this, it's definitely getting, you can see that dirt coming down now. Let me move you over a little. There, see that? So that's what I'm talking about. I think that's grease. Yeah, I'm pretty sure that's grease. I don't know why that would be so dark. It sure has a grease smell to it. You can see the little puddles here. So that's what I'm dealing with. I think we have bearing problems. Great. So it's going to be interesting. I don't know if I'm capable of fixing it, but we're going to give it a shot. So there we go. That's going to start the new year. I'll bring you along for the ride. Well, before we get too hasty here with the headstock spindle noise or the bearing issue, I showed you the grease that was coming down. I sprayed a lot of WD-40 there, and it was really coming out dark. It could either be grease from a sealed bearing or rust and dirt and debris that just got up in there. I suspect it's grease from the bearing. It smells of grease. It doesn't smell like rusty oil, unless rust mixed with oil smells like grease. I don't know. But before we get too hasty, let's take these front panels off. Let's see if we can peek inside the headstock, see what's going on. If we're lucky, maybe we'll even see a bearing and get a picture of a number, of a bearing number, and just see what we're dealing with. Let's get down here and take this apart and just inspect and see what's going on. All right, we have the banjo disassembled and the belt taken off, so there's no pressure, there's no resistance on this spindle, and I can definitely tell something's going on. I think the bearing is going out. If you feel, I don't think this should spin freely like it's, you know, on ball bearings or anything, but it's definitely got resistance. I don't know if that's how it should be, but it's got some braking action to it. So I suspect that we have got, I think that for sure the front bearing is going out. So I'm going to have to address this one way or another. You can see the bearing in here moving. Yeah, I just need to keep inspecting this a little bit. But before we take all the nuts and all this stuff off, let's take a peek inside these panels and see if there's leakage coming on the inside of this as well. I think the next step is to get inside these panels and just take a peek. Let's see what's going on. Not much to see in there, but I'm going to show you anyway. Well, we got this panel off, and there isn't a whole lot to see in there, but what can you see? You can see that grease line. That bearing is definitely shot. Now, what's interesting is that bearing has to press on from the front, and the back bearing has to press on from the back. It's going to be interesting, but give you a peek in there. That's that grease line over here where the bearing is shot. Definitely going out. And see if I can hold all this. I mean, it spins, but it's, you can hear the bearing too. It's definitely this one. So that's going to be interesting. So I'm guessing that this spindle has to go in this direction, put the bearing in. So if the bearings go on the outside, we have to put the bearing in here first, put in the spindle. The bearing on this side should then slide in and knock in. Maybe we can fashion something to squeeze them together. But it definitely, the bearings do not press from the inside. They press both from the outside. So I got at least a visual now. We see what's going on. Not a whole lot in there to see, but gives us an idea of what we're dealing with. Closer look here in this headstock. You can see that grease line on the inside where that bearing is. So the outer bearing, the front bearing is over here in this area, and you can see, let me grab a pointer, and you can see that grease line, grease coming out of that bearing. Kind of hard to focus there, but yeah, it's definitely coming out of there. So that bearing is shot. It's leaking. I could probably keep squirting some oil in there, but the bearing is shot. It's probably a sealed bearing, and I think it's shot. Unfortunately, in here, I cannot see any markings or anything. The bearing does not get pressed in from the inside. What's further interesting is the bearing on the back side doesn't get pressed in from either side. So it's not like you put the bearings on the shaft first and then press the entire thing in one direction. It appears that, I don't know, I think I'm just gonna have to tear into it, but what I think you have to do is put the bearing in over here, probably put in the spindle from the right side over here, push it in left so the bearing will then seat. And then once this is in, the bearing, I'm guessing, is going to have to come in from the back side here and be pressed in with all this mumbo jumbo pulled off and then seated into this headstock. Maybe it's not going to be that difficult to get set up if that's how it's going to be, because I can get this side in, pressed in, and then push in my spindle, fasten all this, make sure it's really secure so this bearing can't come back out over here, and then we can press in or tap in the bearing on this side. Pretty interesting stuff though. And also you can, if I spin this, you can hear that's this side, the bearing, but it doesn't spin either. There's no, I'm not saying it should be like riding on glass, but there's some friction and resistance there. So yeah, we got an inside look and kind of getting an idea of what I'm going to need to do to tackle this. Well, I decided there's not really much left to do that other than get on with it. So this bearing isn't going to fix itself. Not sure if I'll be able to do it. I think I can. I think what the plan is to take this nut off, take the pulley off, get the spindle pulled out of there, and then knock the bearings out and find out what kind they are. And then we'll have to order some. I'm going to order some high quality ones if I do figure out what they are. If I'm going to go through the trouble, I'm not going to buy some cheap bearings off of Amazon. I want to get the real deal. So I think the first thing we should do is, we got the power pulled. Let's take this panel, this LED off. And that's broke. Maybe I'll see if I can find a replacement one of these too, since it's damaged. Pretty simple little part. But we'll get this out of the way. That way it's not causing any issues. We'll put that over here safe. We will kind of clean up a little bit so we got room to work. And the next thing to do is take the lock, the jam nut, the lock nut off, and just make our way through this so we can tap out the spindle. Well, fortunately, my ER40 collet spanner wrenches are going to work out for taking this nut off. So I'm pretty happy about that. Looks like everything is just tightened on there, nice and tight. There's no loose moving parts. So putting everything back on, I don't think is going to be too big of a challenge. I think what we'll do is remove that bolt that holds a cover on. Maybe. There we go. And we'll just put it with our parts. I think we're going to remove this. This will, we'll just get that out of the way so it's not, so it doesn't get damaged or anything. We got our, I think it's this size. There we go. And that's what holds on the RPM sensor. Set that over here out of the way as well. That takes care of that. I was looking at these little magnets. I think they're just slip fit in here. Interestingly, I don't want to lose one, but they seem to wiggle. Yeah, they just pop out of there. So, kind of interesting. Not sure. I don't want to lose those, so we'll put that one back for now. Let's take this off. Just tear into it. So, let's see. I think it would have to go this way. Let me grab a mallet. I think we might have got her. There we go. Now this one needs to come off. There. There's that. This pulley should slide off, and it does. I do have a spare one of these if I need it. Some grease to clean up. All right. Let's see, this gear, this assembly, this is where I start trying to figure out what I need to do. Oh, okay. All right, this is coming apart much nicer than I thought it would. Happy about that. Let me grab my gloves. So there's a keyway, a key, that this is not part of. All right, I think I should take these magnets out of there before I lose them. Maybe they don't need to come out of there. Let's take this key out first. There we go. Got the key out of there. This should slide off. All right, set that over here. Okay, that appears to be it. Let's clean that. Keep big old burr there. Check that out. Yeah, burrs and trash in here. Not surprising, but I'll deburr this stuff. If I'm going to have this stuff apart, I might as well go ahead and deburr it. I think in order to get this off, I think we just need to pound it that way. It shouldn't just slide. I'm going to have to pound it. And then I'll have to take this plate off in order to get this cover off. But that's okay. I've done that before. But I don't want to do that until we get this out. I think the next thing is get a block of wood and see if we can't get this spindle pressed out of here. Let me put a piece of wood down here, or I'll use some of this material here. And a block of wood. And I don't see any other way to get it out of there except tap it out. Now we'll see if, I don't know if this will be, I'm going to use a more substantial hammer here. I don't know how else I would get that out of there. I'm not going to be able to press it. I don't have any pullers. I think I'm going to have to just tap this thing out of there. I'm going to move the camera so I can get a better angle on this. Let's see if we can make some progress. I'm going to put a mark here. There we go. See if we can't see what it's doing. All right, I'm going to move you, and we'll see if we can't get this thing out. That's working. And it made a difference. Interesting. It's not fixed, don't get me wrong. Definitely going to need to replace them. But that's probably more like what it should have done. If you notice in previous clips, this was binding up. So let's carry on. It is moving. Let's just get this thing knocked out. I need to take this back guard off. The bearing is actually wanting to come out. So let me get this back guard off because it's causing some issues over here. I can show you over here. We are coming out. Let me show you real quick. So you can see we're coming out of there and that bearing is wanting to come out. So when we knock this in, I will have to support this back bearing somehow so it doesn't want to push out like that one when we put everything back in. But it's coming out very well. Very interesting. You can see all that grease. So it's definitely had grease in it and it's packed or failed. I don't know. Maybe they're tapered bearings. I don't know. Let's take it apart. Regardless, we're going this far. We're going to keep going. Let's finish knocking this thing out of there. It's going to be a mess, but it's coming out. Let's keep going. They are tapered bearings. Hopefully that's not a problem. There it is. It's definitely a tapered bearing. So now we need to get this cleaned up and just see if there's damage to it. And I'm pretty sure there is. It was leaking. I don't think it's supposed to be leaking. See what we need to do. So there's bearing races that we'll have to deal with. This, I don't know, maybe I messed the thing up, maybe not, but we'll figure it out one way or another. This back one seems okay. Let's go examine this and see what's going on. Well, let's get this cleaned up and evaluate what we have going on. Tons of grease. That might be our problem. I don't know, that looks like thick grease. It's not really a seal, I don't think, but kind of caked in there. Whatever that is. Pretty thick. I don't know if that was supposed to be a seal. Looks kind of like just thick grease. It doesn't look like it was a gasket or a seal. Okay. I've never tore into a bearing or anything like this before, so many of you are going to notice that I don't know what I'm doing, and that's okay. Just remember that when you're commenting. I'm learning. I'm trying to figure this out on my own. I am no expert, but hopefully anyone else curious about tearing into their MX400, 600, 210 MV, whatever version that has this headstock assembly, find some value into tearing apart this headstock. I was having trouble finding this specific model of lathe and details on how to tear into it and what it looked like. So hopefully this is a video that fills that gap on the internet that doesn't seem to exist. Let's continue to clean that up. Now this, I don't know if that's right or wrong, or is that loose like that? Is that normal? Should it be tight? It does spin. Maybe it just needs repacked. I don't know. We're going to find out. I don't know what failed and why it started leaking, but it certainly wasn't moving freely like it should. Maybe they just need repacked. Maybe it's that simple. I don't know. Let's clean out the grease out of this thing. I'm going to do this over the trash can. All right. Okay, well, let me get these gloves off. Okay. Here's what we're dealing with. Here is inside of the Vevor MX400 210 MV. I believe the MX210 line, it could be a 600, 800. It all has to do with some of the accessories that come with it, whether it's that brake clean cleaned all that paint off. Whether it's 8, 16, it depends on the length of the bed really, and some of the accessories it comes with. But this is loose. Now, my question is, should that be loose? Probably. I mean, could be wrong. It's spinning. That bearing's not spinning very well. I don't know. I'm not sure how tapered roller bearings work, but certainly pack more grease in there. But if there's pressure on it, they're not all I don't know. Well, I got to do some research and find out about replacing these, or you know, what I need to do exactly. Maybe I just need to repack it, but that's what's inside taking that spindle off of there. Now, if all I need to do is pack grease in there, we'll just have to tap it back in, and we'll have to secure that back bearing somehow so that it doesn't pop out. But we'll figure something out there. But that's the spindle. It's got a little rust inside that seal. So this is a seal. Okay, I'm gonna do some research and I will be back. Well, they're tapered roller bearings that are in that headstock. I got the spindle out. It really wasn't too terrible to get it out. Now, I don't know if this is gonna be an issue, but I don't know how to tell if these are actually bad. Is this tapered bearing supposed to move like this? I did clean all the grease out of it, but maybe this thing just needed re-greased. I'm not sure why this seal started leaking and oil was coming out the front. Maybe it just needed tapped back into place. I'm just not sure. I haven't moved this or taken this off. I was going to wait before I bother doing that, but I know there's going to be a race, an inner race and an outer race. You know, there's our outer race for that. I may have some trouble trying to get that in and out. Again, maybe I can make a puck or something, or find something to be able to fit in here and seat that in. Of course, I can't use my lathe to make something now, but I'm sure I could figure something out. But maybe this isn't bad and doesn't need replaced at all. I don't know. I've never replaced any bearings like this before. I haven't touched the back side. They seem to be okay. Kind of thinking maybe I should just leave those alone. They're quiet, they're not leaking. There's no issue there that I'm aware of. So better well enough alone on this one, I think. Let me know your thoughts. Perhaps I just need to re-grease it and pop this stuff back in. I don't know. I don't know why that started leaking, but it certainly makes sense now why that grease was dripping out of there, because it was just packed full of grease. I just wonder if it got too hot and maybe it just needs new grease. So here's that bearing once more. Do I just get a special type of grease and just re-grease this? Or is that bad? I don't know. Let me know. Could use a little help on that, and then I'll just have to figure out how to get this thing back together. Well, not sure what I've gotten myself into. I think we can get this back together. Considering I don't think there's any problem with the inner race, I think we're just going to put this back together. The bearing looks okay. Oh yeah, and they're they're tapered roller bearings, by the way, not sealed bearings. I think what happened was it got warm from that big chunk of steel, this thing that I was turning, and it ended up just overheating some of that grease and it started leaking out. I don't believe I needed to take this thing apart quite yet. However, it wasn't spinning freely, and I thought, let's get in there and inspect it and see what's going on before any real damage is done. So I think I could have ran it for a little longer, but this is a good process to go through. I've never changed out bearings. This is not a how-to video. This is just giving you guys a view inside one of these things if you need to tackle it yourself. Hopefully you get a good visual of all the components and all the parts, so you know before you tear into yours what you're going to expect. So today I've decided, since everything looks okay, I'm just going to repack it with some fresh grease, and I'm going to figure out a system to put this thing back together. I don't have proper equipment, so I got to get creative and figure out a way to do it. We're going to get everything put back together, hopefully functional, and hopefully it's spinning more freely than it was before we took it apart. And we'll be back in action. At least we'll know in our mind how this thing gets put together, how it gets pulled apart, what's inside of it, and then what we're in for if we decide we need to actually replace those bearings. They may need replaced, but they're still functional. I think I want to put it back together before I go and invest any, significant amounts of money into that process, or maybe tooling. I just want to get it back together to make sure I can get it back together and get this thing operational again. So that's what I've gotten myself into. So that's just what we're going to do. Today, this morning, my goal is to get this headstock put back together, get this lathe functional again, and see if it's operating any better. There's going to be several challenges, but let's get on with it. We can talk about it all day, but it's not going to get done until we get started with it. Let me bring you over to the bench. I want to show you the components pulled apart, just so you have a visual. There's a reference in the video in case you're trying to look for information. I had a hard time finding information about this specific lathe, so let's get over here and I'll show you the components that I removed, what it looks like, and then we'll get started. Well, I've got you down here. I'm going to throw a lot of pictures in this video of the components, what this looks like. This was the trouble that I had trying to find this information on the internet. I did manage to find one person. It doesn't mean that there's not videos with tapered roller bearings and all that, but specifically the Vevor line that's like the 210, WM210 series, or the MX400, which is what mine is, or MX600. All of them, I believe, have the same headstock. And because of that, they're probably all going to have tapered roller bearings. I could not find that information on YouTube. I did find somebody who had a different model, and it was actually sealed bearings. So that's what I was actually expecting to see in this lathe, but that's not what came out of it. They're roller bearings, tapered. So to get this off, you saw in the video, you take the two lock nuts. You got the jam nut and then the nut to hold everything together. Then you have your pulley, then you have your gear, and then you have the sleeve that's really a spacer, but in addition to that, it's got magnets for your RPMs, and then threaded end. There's a bearing journal. This is all about the same thickness here. The bearing that's inside the headstock, I did not take that bearing out. I'm going to assume it's also tapered, but that doesn't mean it is. This is Vevor. It could very well be a sealed bearing. I'm not going to take it out. It's functioning. It's running very smoothly, and I don't want to go any deeper into this yet. I now have a picture of what needs to be done. But there's a journal here, and then there's a shallow space here, and then there's a thicker journal where this bearing seats. Then there is a seal plate of some sort. I don't know how it didn't leak earlier than that, because there's no rubber seal, there's no gasket. If there's supposed to be a gasket, that's gone. I mean, it's disintegrated, it just didn't exist. And then you have your mounting plate. This does not remove, which is kind of bad because makes it harder to install everything, but it's good because you can run this in forward and reverse without worry about this unthreading from your spindle. That's what we have. That's what makes this unit up. This is supposed to be a Morse Taper 5. You can see it does have a grind in it. I don't know. I don't have anything Morse Taper 5, so I don't know if it's true or not. That's what we have. So what I'm going to do, the plan is just to put this thing back together, mostly to see if I can. If I can't get this thing back together successfully, and I just totally botched this lathe, there's no sense in buying new Timken or SKF bearings or anything to replace these with. I'm not sure they even need replaced. I'm hoping that it's just a grease needs to be, it overheated and started leaking out, so I'm going to use some good quality red tacky grease, high heat stuff, and we're going to get this thing back together. If I can get this thing back together, my confidence is up. I know I can get it apart, and I know I can get it back together. And then if I ever do need to replace these bearings, I can either get a puller, or I could figure out how to do that. So that's going to be the goal today, is get this thing back in the lathe, get it operational, and get everything back in and turn some steel. So let's just get on with it. I'm going to try to give you as many close-ups, as many shots, all the things I couldn't find on the internet. I'm going to try to share with you, and I hope it helps somebody else out there. So I want to clean this up a little bit more with some brake clean, get some of this paint off the inside before we put it back in, and then we're going to pack this with some grease. There we go. All right, I got that cleaned up. There was a burr there I wanted to get off. I got the excess paint off. Next thing we want to do is lube this up. I know there's proper ways. If this wasn't on here, you put a dollop of grease in your palm and you squish it in as best you can. I'm not going to take it off of here, so I'm going to kind of do it the opposite way. I'm just going to squish it in as best I can. I'm going to make a horrible mess, but I don't care. I want as much grease inside this thing as I can get. I'm going to pack that thing full, and then we're going to start reassembling this. You know, I think I was getting a little ahead of myself. I think now is a really good opportunity to take some measurements before we reassemble this thing. It's apart. In case I need to order some more bearings, you got to take it apart to find out what you need. Now, I don't see any visible markings on these bearings. Perhaps they are on this inner race, but I can't see those. They are, it's smashed up against here. I would have to take that apart, and I don't really want to do that. So at the very minimum, I want to take some measurements where the journals are. As I was saying, I'm not sure how to measure the actual bearing, so I'm just going to take some measurements best I can. Now, this should be metric, so we are going to set the Mitutoyo to metric. It's cold, so it's pretty cold out here today. there is a small lip on the bottom of this where I can get, I believe, a decent measurement of the actual journal. I hope anyway. There we go. .44, so that's 45 millimeter. I'm going to write down what it is though. It's 44.95. 45 millimeter. So maybe that's a standard. Let's draw a picture here. It would be nice if where the rear bearing rides, it's actually smaller than 45. Otherwise, if I was to replace this one, it's got to traverse both. But I suspect it's also 45. Yes, that's 45 as well. And this is just to give me an idea, something to search for. But, you know, some of the rougher parts here, it's 45. It's actually machined pretty close to 45. So 45 millimeter. All right, so the bearing journals, the inside IDs, 45 millimeters. So I don't know, I think I'll measure in the headstock the actual bore for the outside diameter. I can do that. I'm trying to think what else, what else do you measure? Maybe the thickness of the bearing. 19 millimeters thick. Maybe 19 is it. So maybe that's a size. I just want to do some research. So I'm going to call that 19 millimeter thick for the roller bearing. And then as far as the race, I'm not sure if I'll be able to measure the race. I can't really. I don't think I can. I can't really measure the race, but I'll bet you it's close to 19 as well. But I might be able to measure it in the headstock. Okay, let's measure the headstock and then we'll get on to packing this thing full of grease. 84.91 millimeter. Let me measure it elsewhere. I'm going to, assuming is bad, but I'm going to call that 85 millimeter, assuming they went with some sort of standard bearings. So I'm going to say the OD is 85 millimeter. Yeah, so 85 millimeter. Not really sure what else I can measure there. I think that would be your critical component. And then on the back side, let's measure this bearing as well. The ID anyway. A little smaller than 45, but it's a press fit, so that makes sense. Okay, so 45 millimeter IDs and 85 millimeter OD. And then, oh yeah, let's do this. Let's measure the depth. Try it that way. Yeah, that's 19 millimeter. There we go. So 19 millimeter thick is your bearing and the races. All right. This is not scientific. It's just some notes. Since the thing is torn apart, I might as well measure what I can. It appears that the bearings, and if you know, if this is a standard size of bearing and you're familiar with this stuff, please put it down in the comments. I'd like to know in case I need to tackle this thing again. But it appears that the ID, the bar, the journals are 45 millimeter. So the bearings are just undersized. Maybe that's a standard bearing. I hope it would be. The OD is 85 millimeter. And that's press fit into the headstock, and the bearing itself the thickness of the roller bearing is 19 millimeters wide, and the races also appear to be 19 millimeter wide. Hopefully that's all standard, and all of you understand all that better than I do. That's what we have. I think those are the primary dimensions I needed to measure. Now it's time to grease this sucker up and get it over there and see if we can't get this thing put back together. You know what, I was going to delete all these clips. Sometimes I feel pretty stupid. What is this going to do? I'm clamping the dang spindle together. That's not going to work. Duh. Alright, I'm going to put that in there because, again, this channel's about making mistakes. The only way that this would work is if I actually did have this sleeve protruding and I'm able to pull it in that way. This setup can work. It's not going to work the way it is. Let me rethink this, and I'll bring you back. I'm going to slowly tap this on and see if I can get it to come on without bringing this bearing out. I'm sure that it will want to come out of there. But let's just see. Maybe that's how they assembled it from the factory. They just put all that in and then they tap this in. So that's what I'm going to start with. But if I see this move at all, then I'm going to stop and regroup. That's pretty close. Well, let me play with this. I want to review a couple things and then I'll bring you back. Well, got a few challenges to figure out. Let's go ahead and start putting this back on so we can draw it in with the nuts. Down there. Like that. I definitely need to come out further because this had way more threads than that on there, so let's keep working at it. Taking it slow. I know I need to come in a little bit farther. We're really close though, but I need to seat this front bearing. It needs to be tighter than that, so let's come in a little bit further. I think that's good, and I think we can actually tighten it down. Now I know there's some preload you're supposed to put on these things. You know, I know with like cars, automobiles and stuff, you want to tighten them up and then back off the nut. And I'm not sure about this. What I'm going to do is just get this as good as I can. I've been told give it 1 thou of preload. We're just going to see how we can do with that. But I got that seated there. There's no movement now. So I think now the next step is to get this tightened up, and then we'll check for run out before we put our lock nut on. Now the real challenge I think is also going to be seating this seal somehow. I got to get creative here, figure out how to put something around and tap that in. I'd like to do that before too much, but I think for now we need to tighten that up and check for run out. Here's what I'm doing to test. Now, I haven't snugged this up yet. I'm just trying to see how we're doing. I've got that tapped in pretty much as far as it will go. I think the next will be to seat it with some preload and get it on there, but I just wanted to check. I'm about 1 thou of run out on this lip. Now, perhaps this isn't machine true. It could be one thou out. I think if I remember testing originally, I was always about 2 thou out anyway. Not that I want to accept nothing but perfection here, considering what this is and what I did and took it apart, put it back together and pounding and tapping on it. I think 1 thou without having the nuts and everything turned down, tightened up, is acceptable to me. So let me show you. We're on the 0 and we slowly move this around. It goes up a little bit and then it comes back below the 0 and then we come back up right there. So we're above the 0. So we're about 1 thou. I wouldn't say it's a 1.5 thou, maybe 1.5 thou, but we're about 1 thou out without this being tightened up. I'm gonna go with that. I really don't know what I could do to improve that at this point, but I'm ready to tighten this thing up and get this back together. I do need to get creative on how to seat this front seal, but that's what we're gonna go with. So I'm gonna get this tightened up. Again, we're just gonna snug this down and then we'll put our lock jam nut on there, and then I need to figure out how to seal that back up. While we're watching this run out, we'll check this together. I don't really have a good light over here, but you can see that we're actually 1 minus 0. Good enough. Let's see how things are looking. Hopefully they aren't more than 1 thou and a half out. Got everything snugged down the way that I think it should be. So we're coming up 1 thou. Actually, back here, let's mark this thing again. We're at this. This is 1 revolution. All right. So we're at -1. We're coming up to 1. We're coming back down 1, 1.5. So that's the same as it was. That's how it was from the factory as well. Actually, I think it was 2 thou. Regardless, I don't think I'm going to really get it any better. Everything's put back together the way it should. I think now the next step is to get everything cleaned up and buttoned up and put back together and give it a test. I wanted to just show you that. So we are about 1 thou, 1.5 thou out of run out. 1.25 thou. So I'm working on trying to get that plate put back in there. So I've kind of got this, I don't know, maybe they make a special tool for it, but I'm trying different things. I'm gonna try this little piece here, see if I can't get that thing snugged in there. But I thought I would share. This is gonna be a challenge for anybody. If you take this thing apart, how do you get that back in? You know, because you don't want to pry on that and bring out your the spindle, and you don't want to pry on it anyway. So, you know, and the other thing is, it's got a seat in there because it's a seal. But when you do one side, the other side pops out. So this is, I may have to wedge something in there on the other side to keep it from popping out. Yeah. Yeah, so anytime I get it on one side, If I get one side, then the other sides pop out. So I got to come up with something a little different. But anyway, I thought I would share. It's going to be a challenge. Maybe I'll make a tool someday, or I'll find a tool, but I got to get that sealed up before I even use this thing. Well, I got that seal on. I'm not going to show it, but what I ended up using was my clamps again, and they're just about the right thickness. I was able to get that in here and just tap on this side to seat that, and so that actually worked quite well. I then decided that I would check the the preload and all that. If you remember right, when I disassembled it, it felt, I had commented on how that didn't spin freely. I mean, it spins freely, but it doesn't just spin without resistance. So it is the same as it was, so I'm going to go with it. Maybe the bearings need replaced still, I don't know, but I got plenty of grease in there. This is what I'm going to go with. So now it's time. I went ahead and snug down my nut, and now I'm going to put the jam nut on there, and just to keep everything nice and locked in. So hopefully, I want to do that. If I get it right, backwards here. All right. Come on. I'll check for run out one more time now, and if that seems to be okay, we're gonna go with it. If anything, I learned a ton. So let's check the run out. Let's get this thing back together and see how operational it is. Now we can put this on, and if you do take yours apart, don't worry, it's got two different sized connectors. The only thing is, I might have put this thing in upside down, so I kind of want to test it. So before we do a whole lot more, let's just give that a test. It's correct. Okay. So there's that. Let's go ahead and screw this on. That way that's buttoned up. Boy, the quality of this plate is so bad. It's just got holes everywhere. I think this plate and this headstock is made for different machines, maybe. I don't know. It's pretty bad. Don't buy one of these V-boards if you're looking for a showpiece, because you're not gonna get one. Let's get this on here first. Okay, we have the grease on there with the front line. We have our seal, put that on. Now let's go ahead and start reassembling this into different components. And give it a test. Next time we'll just put the camera on here. That's what I call it. That's gonna go kind of up here and up. Oops, go like that. So remember right back, we'll just go back. That one. So you get in there. Try to. Well, let's plug her in and see. Let's see what this thing does. We'll turn it on very slowly. Well, that's what we're going with. Let me finish buttoning everything up. Make sure I got everything mounted the way it should be. Put my splash guard back on, clean everything up, and we'll do a test cut. Still out, out. I think it's down there. We got everything put back together. Got everything crammed in as best we can. We're going to do some tests turning on some 12 14 before we do that. Let's do a RPM test now that we have kind of everything mounted in here. Let's just see what happens. Let's see what it sounds like. You hear a little gear over here. Not too bad. This doesn't sound too bad. We get all the way up to 1250. Well, we had her up to 1283. I don't turn anything that fast. I don't see... I mean, there's some residual grease from when I put all this together back here, but okay. Let's do a quick turn and then we'll do a summary of this video. Let's see what happens here. Doesn't look too bad. Keep in mind that this carbide insert that I have has been through several projects now. I just finished up those C-clamps, that 3-inch C-clamp, so I did a lot of turning with it and I haven't really put a new edge on it. 12L14 always turns out looking really nice, but yeah, that did good. We have our lathe back up and operational. quite happy with that I was able to take it apart and put it back together and actually still use it. So let's do a summary of this video, and we'll talk about what we learned, and hopefully this will help anyone else looking for this kind of information. I wanted to close out this video and summarize a lot of the things that we learned about this. I didn't know what I was in for when I tore into this. I was really hesitant to do it. Some friends of mine, they're like, just get on with it. You know, you're not going to learn anything if you don't. If you think it's got a problem, take it, tear it apart, look and find out what needs to happen. So I decided I'm just going to do it. What's the worst could happen? Ruin the lathe. You know, I can deal with that one way or another. So I decided I'm going to find out what's going on. It was leaking some grease. I think I know what happened to begin with. And I wanted to find out if they had sealed bearings and those were failed. Well, lo and behold, this thing has tapered bearings, at least in the front. I didn't take the back bearings out. Those could be sealed bearings, but I suspect they're also tapered bearings, considering the front is. And I was able to investigate. The bearings looked okay. The races looked okay. In the end, I think what happened was when I was turning this large chunk of steel that I showed in the video earlier, I think it just got warm. The headstock got warm from the pressures and the turning of that large chunk of steel, that heavy chunk of steel. And I think what happened was I exceeded the drop point of the grease that was in there, or at least some of the grease, and it started coming out because it turned into oil. I believe that was the source of the problem. I don't think I needed to tear into it, considering now that they were taper bearings and there was still tons of grease packed in there. But now I know what I've really learned is I can take this spindle out if I have to, and I can put it back in if I have to. The only thing I didn't do was replace the bearings, the inner race that was press fit onto the spindle, but I think I could tackle that. I might consider purchasing bearing puller tool set or some sort of additional custom tools that would help me with that project. But for the most part, I know that I can get this thing apart and I can put it back together. I really hope that I captured enough visuals, captured enough close-ups, captured enough details for anyone that's looking to or needing to replace their bearings or find out what's going on with their spindle and their headstock in one of these lathes that you might have. I had a lot of trouble finding, matter of fact, I couldn't find anybody with this specific headstock, which again is on several different models, who has actually tore into it. The one video I did find, they were sealed bearings. It was a different style of headstock. The motor was sealed and it was mounted different. It just wasn't the same. And he had sealed bearings. So it was similar to take it apart, but it wasn't the same. So I really hope that this helps somebody out there. If you haven't subscribed, please do. Please give it a thumbs up. If this is helpful to you, I would appreciate the subscription and a thumbs up. And I just really hope that it helps you. Thanks for watching, everybody, and I hope to see you on the next one.